Hi, I'm Duane Knudson, and welcome to a presentation on a few challenges of problem-based learning. Teaching and learning with many students is a complex system, just like the biomechanics of human movement. So this video will highlight a few challenges to look out for in trying problem-based learning instruction in your classes. First, problem-based learning, like other active learning instructional techniques, requires faculty to give up some control of the classroom to harness the energy of peer teaching and students' personal interests. We have to get comfortable with being the guide on the side, not the sage on the stage, with every interesting question and answer in our class. Second, good problem-based problems or questions are the right mix of real-world importance of interest to students that must be balanced against the evidence-based, highly contextual, client and environment-specific answers often needed in real-world professional practice. Unfortunately, students love big picture, easy answers, but we all know the real world is complex and contextual. We need to come up with a problem or question that's not too general, so students don't miss the instructional objective we're going for, yet not too specific to give students room to refine a question and answer and a solution to that solution to that problem. So we need a good general problem with importance and some real-world context to inspire the hard work of learning, problem solving, and applying knowledge in our class. In other words, a good general problem. We must challenge the students in the difficult application of biomechanics knowledge that the students can narrow down a little to answer successfully. And a few hints to try to come up with these general level of difficulty. First, we want the knowledge of application of biomechanics to be difficult for most students, so when they work in a team they can be successful. And this focuses, of course, on performance improvement, injury reduction issues, remediation of injuries, biomechanical effects of equipment, or biomechanical effects on the rules of sport or activities. We can think of problems that are surprising or counterintuitive that can challenge students to their thinking. And we can also focus on some sort of current or professional controversial issue, and that really helps students get engaged in topics. For example, running shoes haven't been a big deal until recently again, when barefoot running, minimalist shoes, and now maximalist shoes have been popular. So you need to come up with a question that's not too general. For example, specific is, do running shoes matter, or do they hurt or help? Are they your friend or foe? Of course, that is too general. We need something to talk about, or a topic that is a little more specific about, does running shoe have biomechanical effects on what biomechanical outcome in what athlete, or what type of injury or person? And if we start with that sort of context, that is a good level of difficulty for students to build something on. And then when we get them to work in class, we have to guide them. And our job as instructors, again, is not to answer the questions, but to encourage students to ask questions of us that we can help them with, and encourage them to ask questions with the research or the data or the professional practice that they must implement this biomechanical knowledge in. And then follow-up questions on all 4 tasks of problem-based learning. When they're evaluating and constructing a research question itself, what sort of questions do they need to ask? What sort of knowledge do they need to be ready to answer that question? Oftentimes have to deal with group dynamics. A challenge is often to get 3 to 7 different personalities to work together well. What is their plan to answer the research question? What are the steps? How do they find knowledge? Where do they look? How do they weigh and evaluate that knowledge and come to a consensus as a group? And of course, the last couple steps is presenting your results effectively, or solution effectively, and again, responding to the instructor feedback to improve and make final revisions. So, not the time to do when you're in class. Again, it's not the time to present research or do reading. Remember, the idea is for you to be on the side, keeping the students focused on brainstorming. How do they collaborate together? How do they remain organized? Who does what when? And again, focusing on the outcome itself. What is the instructional objective? What is the evaluation, synthesis, or analysis they need to do to come up with an answer to that specific question? But when you think about it, all these challenges are just like all the challenges we face in other instructional challenges instructional strategies as we try to get our students to apply biomechanics. Getting to apply biomechanics in new and difficult contexts is difficult. So don't let this discourage you. We hope you plan to try out a problem-based learning activity and discuss it with your peers at the ISBS session. Thank you for your attention.